Hello, this is Russell Hawley speaking to you from the Tate Geological Museum in Wyoming, and today I'm going to talk a little bit about Eurypterids. Now, Eurypterids are an extinct group of arthropods that are sometimes called sea scorpions, but it's not actually a very good name because they were not scorpions. They had some important differences. Instead, their closest living relatives are these guys right here, horseshoe crabs. Now, a horseshoe crab has compound eyes, and the Eurypterids seem to have had compound eyes as well. So that's one similarity that they've got. Scorpions, on the other hand, have simple eyes. Each eye can only tell whether it's light or dark, and they have a variable number of eyes. Some species of scorpions have no eyes, some have 12. The average seems to be around 8, but their vision is not great. And the other difference is the way that their limbs are adapted. In a horseshoe crab or Eurypterid, there's a pair of chelicerae, pincher-like organs, and then behind that there's 5 pairs of walking legs. On a scorpion, the chelicerae are pinching, feeding organs, but the first pair of legs is modified into a pair of pinchers, and those are used for manipulating, seizing prey, but generally not for walking, and they do their walking on the 8 pairs of legs behind that. Here's an example of a scorpion. This is a model of Paleophonius, which is one of the earliest fossils in the fossil record, and indeed one of the earliest land animals in the fossil record. So long before fish ever crawled up onto the shore, it looks like scorpions had beaten them to it. Now, Eurypterids, we've got some real ones right up here. These are some actual Eurypterid fossils from back east. Sadly, Eurypterids are fairly rare in Wyoming, but here we've got a couple from upstate New York belonging to the genus Eurypterus. There's a model of Eurypterus here, which gives you a better idea of its overall body form. In many Eurypterids, the rear pair of legs was modified into a pair of flat paddles that may have been for actually swimming right through the open water column, something else that a scorpion cannot do. Here's another Eurypterid. This one's called Styloneurus, and on this one, the hind pair of limbs is long and spider-like and would have been used for walking. Incidentally, no Eurypterid seems to have had a venomous sting at the tip of its tail like a scorpion. Instead, they had a telson, either long and straight, as it is here in Styloneurus, and you can see that same long, straight telson design in the modern horseshoe crab, or in other Eurypterids, it was flat and might have been used as a paddle for swimming through open water. And here is an ancient horseshoe crab, Bunodes. The opisthossoma, the rear portion of the body, is segmented. This is a difference from modern horseshoe crabs, in which all of those body segments are fused together to form a single solid body segment, the opisthossoma. And the other details of its anatomy are a little different, but it's the same basic body plan that you see in the horseshoe crabs of today. And then this is Strabops. This is an arthropod from the Cambrian period, and it is a very generalized sort of critter, and although it's too late in time and too specialized to literally be the great granddaddy of the horseshoe crabs, it's very likely that the common ancestor of horseshoe crabs and Eurypterids, and possibly even trilobites, would have looked something like this, like little Strabops. Now, in the Beartooth Butte Formation of northern Wyoming, people have found pinchers belonging to a group of Eurypterids called pterygotids. And in pterygotids, those chelicerae were at the ends of long jointed arms and possibly were used for seizing and gathering food. Here is what a pterygotid Eurypterid looked like. And one of the pinchers found at Beartooth Butte was 18 centimeters long, just the pincher, which means that the rest of that Eurypterid was about as long as I am tall, which I feel is just the wrong size for something to be when it looks that much like a scorpion.